Okay, so today we're going to be looking at what a geometric series looks like. Okay, so we're going to talk about geometric series today. So let's consider the sequence. U1, U2, U3, all the way up, okay, defined by the recurrence relation U then plus 1 equals R UN. Okay, so R multiplied by the term before, with U1 being our first term, let's say A, constant A, and also R is a constant. Okay, so that's the sort of the recurrence relation we're going to think about in order to work out what a geometric series is. So the first term is A, and there is a ratio of R between successive terms. Okay, so that's what's going on here. We'll start off with a first term A, and then there's a ratio, which means that there's a number that we multiply to get the next term, and then the next term after that. Okay, hence why they use the symbol R. They use the letter R for the ratio part. Okay, so what that would look like actually as a sequence. Well, first term would be U1 is just A. That's the first term. Then U2, well, that would be whatever the ratio is multiplied by the term before it, which is R times A. A better way to write that is AR. Okay. Then U3, well, that would be the ratio again multiplied by the term before that, so it would be R times AR, which would give me AR squared. Okay. And then U4, well, we see the pattern now would be R times whatever U3 was, which was AR squared, which equals AR cubed. Okay. And so on. Okay, so you can sort of see what the pattern is straight away, can't you, when you're looking at the powers here. So in general, what that means for us that the nth term okay, so which is un, would be a r to the power n minus 1. Okay, so if we know the value of the first term a, and we know what the ratio is r, we want to work out what any term in the sequence is after it, the value of n. We just substitute n into that, we'll get the value of that there. Okay, so we'll look at a few examples using this to show you how these sort of questions can work. Okay, some are quite straightforward, some a bit more thinking is required. Okay, but we'll have a look at them. So example 1, find the 10th term of the geometric sequence 7, 14, 28, 56, and so on. Okay, so that's a sequence we've got. We've been told it's a geometric sequence, so our job would be to work out what the 10th term would be. So if I'm looking at my sequence, okay, I need to get the data. So I know my first term was 7, so that's A. A was my first term there. Then R is the ratio that multiplies each number to get the next one. So you can see it doubles every time. Yeah, we double the 7 to get 14, double the 14 to get 28. So then R would be 2. Okay, we're doubling it every time. Okay, so if I want to work out U of n, so any general term, it'd be A R to the power n minus 1. That's what we've worked out as our sort of general term up above. So if I'm working out for U10, 10th term, then A is 7 multiplied by 2 to the power 10 minus 1. Okay, which becomes 7 times 2 to the power 9, which gives me an answer 3,584. Okay, so we can see that we didn't have to go up any further in our sequence. We could actually just work out using that. Is that okay for our first example? Does that make sense? Yeah, quite alright so far? Cool. Okay. So that's what you would call a nice example. Yeah, they give you the sequence. You can work out A, you can work out R very quickly to then work out any other term that they ask you for. Okay. Let's look at a second example here as well. Okay. So find the 7th term of the geometric sequence (45 minus 30, 20 minus 13 and a third). Okay, and it goes on. Okay. So you can see it's a very similar question. It's just maybe a little bit trickier to actually spot what the ratio is here. Okay. So let's try and see if we can solve this. So again, the first thing that we spot is that A is 45. That's my first term. Okay. So that's the bit that should be quite straightforward to see. Now, how we want to spot what the ratio is, okay, what we'll do is, because it might be a bit awkward, is if I look back at my first example, how I knew it was 2. Well, it's easy to spot things doubled, but if I done 14 divided by 7, or if I done 28 divided by 14, or if I done 56 divided by 28, so 2 terms in succession, then they gave me the answer 2, the ratio that came out. So I'm going to do that here. Okay, I'm going to take the 2 terms, divide each other. So you take the second term, and whatever 2 one you pick. So I'm going to pick the 45 and the minus 30. So it's going to be minus 30 over 45. Okay, and that becomes minus 2 over 3. Okay, so that's what the ratio is actually. Every number is going to get multiplied by minus 2 over 3 to get the next term. Okay, so again, if I want to work out the 7th term, let's write down what the general formula is for any n term. So it's U of n equals A to the r to the power n minus 1. U of 7, okay, well A was 45, that's fine. R is minus 2 over 3, and that's to the power 7 minus 1, which means it's going to be 45 times negative 2 over 3 to the power 6. Therefore, we get the answer 377 over 81. Okay, if you put that into a calculator, that's what you should get. Hold it there. No, she's got a secondary class. I don't know when I don't know when first years are. Oh no, well, it might be the ones then if she's not there. If she's not in class, I don't know where. Right, cheers, bye. Okay, so how was that example? Is that alright? So again, same question type, but you can see that the sequence can look a bit more awkward if the ratio isn't a nice thing like doubling or tripling, okay? And obviously, when you see with arithmetic, if the difference was negative, then everything went down. Obviously, if your ratio is negative, then your terms are changed between positive and negative every time. Okay, so that's just things that you can spot there. Okay, but look at one last example. Okay, and you'll see this is going to take up to the next level again. Okay, so example 3. A geometric sequence of positive terms has third term (72) and seventh term 4 1/2. Okay. Our question is to find the sixth term of the sequence. Okay. So you can see this is a step up now. We've only been told 2 terms of the sequence. They're not even terms that are next to each other in the sequence. We don't know what the starting off term was in the sequence. We don't know what the first one was. So we don't know the value of A just yet. And it's very difficult to even try and work out what R is at this stage. Okay, so there things we've got a bit more extra work to get that information here. Okay, so let's see how we would do a question like this. So, solution. So again, we know the general formula is U of n equals A R to the power n minus 1. Okay, so if I use the fact that, well, I know the third term was 72, okay, that meant what the third term would have looked like would have been A R squared, yeah, because 3 take the 1 as a power, okay. Whatever that was had to give me 72. Okay, that's what the third term's telling me there. If I then go to the seventh term, which is 4 1/2, then what that's telling me is that A R to the power 6 was 4 1/2. Okay. And what I'm going to do is I'm going to call that equation 1. I'm going to call that equation 2. So those are my 2 equations that at least I do know. Okay. What I'm going to do, I'm going to, oh, I scrolled up a bit too much there. Let's try that again. So I'm going to do 2 divided by 1. I'm going to divide equation 2 by equation 1. Okay, so that means that AR to the power 6 over AR squared. Okay, so that's the left hand sides of both equation 2 getting divided by equation 1. Well, that still equals 4 1/2 divided by 72. Okay, so if I divide these things, okay, so the a's cancel there, and if I cancel them my powers, I'm going to have r to the power 4. Okay, and if I do 4 1/2 divided by 72, it's 1 over 16. Okay, so what that tells me, if I want to work out what the value of r is, I'm going to take the fourth root of 1 over 16. Now there's 2 possible options, okay? So you take the root, you have positive and negatives. If you do that calculator, or if you actually work out the fourth root of 16 is 2, so that's why you get plus and minus a half. Okay. Now we need to just go back and think about our question. So our question said a geometric sequence of positive terms. So remember, r is the ratio. Therefore, if it's one of these things, which one's it going to be? Well, in order to keep things always positive, if you multiply it, then it's going to have to stay the positive one. But if it was negative, the ratio, it would interchange like you've seen on the previous example. Okay, so we'll write a wee sentence there say, but r cannot be negative a half since all terms are positive. Hence, the answer for us is the positive version, r is a half. Okay. And what we can do now is we can substitute r equals a half into any of these equations to work out what the value of a would be. Alright, I'm going to use equation 1. I think equation 1 looks a bit nicer than equation 2. So, using equation 1, okay, which is ar squared equals 72. Then a multiplied by a half squared equals 72. If you square a half, you get a quarter equals 72. If you times both sides by 4, the value of a comes out to be 288. Okay. So therefore, now I've got my two values that I needed. I've got my a value, my first term, and I've got my r value, which is positive a half. Okay. So therefore, I can now use that to get my sixth term. So the sixth term, so u of 6, well that equals a r to the power 6 minus 1. So that's going to be 288 multiplied by a half, that's my r to the power 5, which gives me an answer of 9. Okay, so that's what the sixth term would be. Okay.